What does relationship mean in a database? Why do we need these relationships? What problems do they solve? Is this something all databases have? What are the main relationship types? In this video, we are going to break all of this down in a very simple, straight to the point way. Before we talk about relationships, let's talk about databases generally, because relationships are primarily a feature of relational databases. Now, relational databases is a type of databases. There are other type of databases. We have document databases that store data in a different way. It's not as formal as relational databases. We also have graph databases. They have relationships as their core concepts in a way, but they function differently. But relational databases are the most common types of database, and they are specifically designed around the concept of tables with relationships between them. So now, what does relationship actually mean in a relational database? A relationship in a database is simply a connection between two pieces of information that are stored in different tables. Now, imagine you are building an e-commerce app, like maybe a small online store for a small business. You would need to store information about your customers, right? And then you would also need to store information about the orders that they are placing, right? So a relationship in that scenario would be something that connects the customer to the order, right? Now, why do we need relationships? What problems do they solve? Because if we think about it, if you have that kind of structure or system, the first or maybe the manual or casual thing to do would be to have like a giant table and just save every order, every customer on this table. And maybe that would make sense at a level. Maybe manually, if you have like a paper or a book, that would make sense. But you need relationships to keep data organized and avoid repetition. So if we have a big giant table for our online store, we'll probably have this table where we have our order ID, maybe the customer name, their email, their phone number, the name of the product they bought, the price, the date they ordered. And for every time an order is placed, we would have something like this, another row on the table. But you can already notice a problem here, right? If you look at this table, there is already an obvious problem. Ade John's information is duplicated in row number 1 and row number 2 because he probably bought something from us twice. He's a loyal customer. Now, if Ade changes his email, we would have to go update it in multiple places because we have Ade John here, we have Ade John here, and maybe Ade John keeps buying things every week. We have like several occurrences of Ade John. So in the case where Ade John changes his email, we have to go over all of those occurrences to change the email of Ade John. And there can even be scenario where there will be typos in a place. So it's very easy for the data to become inconsistent. And of course, in no number of time, this table will become very huge and very wide. I remember one time I used to work in operations and we would keep this huge table and just fill it in. We had like this Google sheet that was running over to, I don't know, so many lines. And that is probably what will happen in our case here for our online store, right? But relationships will help you to split this information into two different tables, right? So if relationship comes to play here, we will then have the customers table and the orders table, two different tables here. Now, in this case, you can see that John's information, his personal information, his name, his email, his phone number, exist in just one single place. The orders he placed are now referencing his customer ID because he has a unique identifier, right? It seems like a lot of tables. Why not just use one table? Why use two tables? But it is more efficient, it is more cleaner and easier to maintain. And in real life scenarios, we will have different examples like this. For example, if you're a student in a school, a student will have so many courses that they are taking. We cannot keep repeating their name or their details for every single course they take, right? If you use social media, we're all on social media. If you make a post on Instagram or on Twitter, a post will have multiple comments, right? Imagine having to register the detail of the post again and again for each comment. And the same thing can even happen in an e-commerce app. A product would have many orders, right? We have a customer, we have many orders, and a particular product too would be ordered several times. So all of these scenarios make it very, very necessary for databases to have relationships. And that's literally the idea of relational databases. What are the main relationship types? We have three major ones. We have the one-to-many, which is the most common one. We have the one-to-one, and we have the many-to-many. And we're going to talk about them one after the other. First of all, the one-to-many relationship. In this case, one record in table A, let's say we have table A and table B. One record in table A can be associated with many records in table B. But each record in table B belongs to only one record in table A. And that's the idea of one-to-many. For example, one customer can have many orders. They can buy something this week and buy something next week and buy something tomorrow, but each order belongs to one customer. One order cannot belong to two customers. One author can write many books, but each book will have one author, or at least maybe, let's say, one primary authors, because there are books that would have multiple authors, maybe. But basically, one book will have one author, but an author can write multiple books, right? Another example is that one country can have many cities, but each city belongs in one single country. You cannot have the same city, except there is a coincidence of the same name, but the same city cannot claim to belong in two different countries, right? But the country can have multiple cities. Let's go back to using our e-commerce example. We have Adejon, right? In this case, Adejon is just one customer, but he has two different orders, order 101, order 102, right? But how is it implemented? Very simple. The many side, the one side is the customer in this case, one customer to many orders, right? One to many. So the way it is implemented is that the many side, which is like the order side in this case, would have a foreign key column that references the one side. Remember, the one side is the customer side, and that is how it is implemented. So instead of for every order, instead of detailing Adejon's information for every single order, you already have Adejon's information in one single place. But for every time Adejon books a different order, we have order 101, Adejon has order 102, and Adejon has order 103, and Adejon has order 104. On the orders table, there will be a foreign key for each of those orders that references Adejon. So your primary key is the unique identifier for each row in the table. It's usually like an ID in a real application. So like the user ID or the order ID, every row will have its own unique ID. But the foreign key, on the other hand, is a column in one table that points to the primary key of another table. It's like a bridge. It's what is telling us, hey, that row belongs to that row over there. This order belongs to Mr. Adejon over there. But this order belongs to Mrs. BC Chinedu over here. Now, moving on to the next type, we have the one-to-one relationship. This means that one record in table A is associated with exactly one record in table B, and vice versa. A real world example is, remember earlier we said countries and cities, but an example we can give for one-to-one is a country and a capital city. You know, a country can have multiple cities, but countries will usually have one capital city. The capital city of Nigeria is Abuja, even though in my head I think it's Lagos, but it's Abuja, right? And the capital city for Estonia is Tallinn, right? So one country can only have one capital city, and one capital city can only belong to one country. Abuja cannot be the capital city of Nigeria and also be the capital city of Estonia. That is not possible. Abuja is the capital city of Nigeria, and it has to be the capital city of Nigeria. It cannot be the capital city of two countries. And also Nigeria cannot have two different capital cities, right? Let's say you have a users table with basic info, you have the name, you have the email, and then you have your user profiles table that stores extra stuff like the bio, the profile picture, social media link. Every user has one profile, and each profile belongs to one user. Same formula, one-to-one relationships. Now you might be wondering, in this scenario, why do we need multiple different tables? Why not just put it in one single table? Because now we don't have the problem that we are having in one-to-many, right? And that's a fair question. Sometimes you actually can. You can just dump it in one table. But usually there are good reasons to split them. And there are different reasons for this. First of all, separation of concerns. You might not want to have everything in the same place. For example, you might want to keep maybe profile data different from authentication data, and that would make sense. And it's in the case of performance as well. Maybe if you have like a large bio, maybe in cases where, for example, on LinkedIn, you can put in like this very large bio. And if, say, LinkedIn does not need to show your bio all the time, it would not make sense to have to take all the user data and fetch the bio with it. It makes sense to keep that separate, right? Since it's not needed and it is large. Another reason is security. You might want to keep sensitive data separate from others. For example, if, what can I use? Maybe if you have, in Nigeria, we have NIN numbers, which is like, I don't know if that is special in a way, but I want to believe it is. You don't want everyone to be able to access your NIN. I want to believe so. I don't know. But let me use, I think the US has a special number of this kind, social security number, right? You may want to keep that in a separate table and give it different access. So not everybody can access this place. There are secrets here, right? So those are reasons why you would want to have data that has one-to-one relationship in different tables. And either tables can have the foreign key. Remember, you still need a foreign key that references the other table. In this case, any of the table can have it, but usually it is always the table that depends on the other one that usually has the foreign key. For example, if you have a users table, your users table has an ID, and then you have users profiles table. It is the users profiles table that depends on the users table. So it makes sense for it to have the foreign key. And in that case, you would put a unique constraint on that foreign key such that a user cannot have two. For example, if there's the users table and the user profile table, a user would not be able to have two user profiles. It's one-to-one. A user cannot have two. So you put a constraint on it. One-to-one relationships are not really common. The last one is the many-to-many relationship, and this one can be a little bit confusing. It means that if you have two tables, one record in table A can be linked to many records in table B, and one record in table B can be linked to many records in table A. It goes both ways. One real example is movies and actors. One movie would have many actors, and one actor can act in multiple movies as well. So many to many. Students and courses would have many courses. I mean, students, every semester I would have multiple courses that I'm taking. And one course, we have multiple students that are taking it. So many to many. And I was making the book example earlier. I think it fits more here in this scenario because books would have multiple authors sometimes. So one book can have multiple authors and one author can have multiple books. So let's remove that example from earlier. Let's use a visual example for students and courses. We have Gbemi and we have Paul, right? Both of them are students. Both of them are taking maths. Gbemi is in math. Paul is in maths. Maths has both Gbemi and Paul. And of course, Gbemi is also probably taking other courses and Paul is also probably taking other courses as well. Another example, social media tags, hashtags. A post can have multiple hashtags and an hashtag can be used on multiple posts. Now, a many-to-many relationship has a very special requirement. You can't link the two tables together. So in this case, you need something that I like to think of as a bridge or a middleman. Because remember, you have your students table, you have your course table. In this case, you will need a bridge, like I said, that is called a junction table. People call it different name. It can be a pivot table, a join table, a linking table, a bridge table, associative table. It has a lot of names. You can just call it whatever you want to call it. But the idea is that it is in between two tables in a many-to-many relationship. So for example, in this case, we have, let's say I have a school. In my school, there are multiple students. This is my students table. I have Bemi, I have John, I have Amy, I have Mary, and I have my courses table too. I have maths, I have English, I have Estonia, I have arts, I have computer science under these courses. Now, in this case, I would have a junction table. And in this scenario, we can call our junction table enrollments. So it is this table that joins the students to the courses. The junction table will usually have two foreign keys. So in our enrollment table, we would have two foreign keys. You would have the student ID and the course ID for every row. So Gbemi is taking 3 courses this semester. There will be 3 inputs on that table, and each of them will have Gbemi's ID and that particular course ID. In this case, Gbemi is taking maths, arts, and computer science. So you have Gbemi's ID, then maths ID, Gbemi's ID, computer science ID, Gbemi's ID, arts ID. And the same thing will go for another student. And the good thing about a junction table in this case is that it can also serve as a place to store other peculiar information. For example, in this case, if I register for this course at the beginning of the semester, there are scenarios where people would have to register for a course, say, in the middle of the semester. Then we need the enrollment date, right? What time, at what point did they register for this course, right? We need their grade. What if they drop the course in the middle of the semester? We can store all this kind of information in the junction table. So on this enrollment table, you can have student's grade, enrollment day. So the table does not belong to the student's table. The junction table in this case does not belong to the student table and it does not belong to the course table. It belongs specifically to the relationship between a student and a course. So any data that concerns the relationship between a student and a course, you can add it to this table. So if you look at it, a many-to-many relationships table is 2 one-to-many relationship. So one student has many courses, one course has many students, and our junction table, which is our enrollment table, is the glue and the bridge in between. So that's it. Those are the 3 major type of relationships in relational databases. And honestly, you don't have to stress yourself about memorizing them. As you start to use them in your day-to-day building your project, you will get used to just knowing them. It will just be like a second nature to you to know that, oh, this is a one-to-one, one-to-many, you will just know. And also another tip for knowing is just try to think of it in a real life scenario. That's what I do. Think of it in a real life scenario. You'll be able to understand what relationship is between those data and how to go about creating your tables in your database. Another practical tip, start with one-to-many relationship. It is the most common. You are always going to use it, and it is pretty straightforward. Also, another thing, when you're naming your junction table, always name it to describe the relationship between the two tables. You don't have to join the name of the two tables together. For example, in our case, if I call it student courses, that's not really descriptive enough, but enrollment is a very good name for that junction table. Anyways, I'm going to leave you to it. If you found this video helpful, please don't forget to comment, subscribe.